Hi everyone, this is Hassan and welcome to my channel Hassan Academy. So today we are going to discuss one particular concept for IIT JEE and NEET, and if you are a IIT JEE or NEET aspirant, you can subscribe my channel so that you can get more and more concept. So let's discuss about first little bit about hybridization. Okay, because this concept is related to hybridization, so you should know a few things about hybridization. Once we are telling that it is sp3, sp2 or sp hybridized, with respect to their different hybridization, their S character is changing. S character, okay. S character here is how much? 25%. Here is 33%. 33.33. Here is 50%. Okay. So now, with respect to once S character is changed, their electronegativity also going to change. Hope you understand what I mean. So if anywhere S character is 50%, another place S character is 25%. So this particular atom is more electronegative compared to this one. And once S character is changing, electronegativity is changing, their basicity also going to change. Now I will take some example where same everywhere nitrogen atom is there and they have the lone pair, but their due to hybridization their S character is different, and so that their electronegativity is different and their basicity also different. So let's write few examples so that you will get very clear example. Clear concept. Let's write this molecule. One hydrogen. Here one lone pair is there. One lone pair is there. This is what? Pyridine. Then I am writing another molecule. Nitrogen. Double bond, double bond, double bond. Here also this nitrogen has a lone pair. This is called pyridine. Okay. Let's take another molecule. Here one lone pair is there and hydrogen also there, lone pair also there. Okay, this is called pyrrole. Okay, pyrrole. Now you see this nitrogen is sp3. This nitrogen is 1, 2, 3, 1, 2 and 3. This pi bond you should not count. 1 sigma 1, 2 sigma 1, 1 lone pair, sp2. Now here if you see 1, 2, 3, 3 sigma 1, 1 lone pair, you may feel that it is sp3, but that is not correct, because this lone pair is always in conjugation, so it is also sp2. Okay, you have to count only 3 sigma 1 because that lone pair under conjugation, so you cannot count. Here lone pair is not under conjugation, here lone pair is not under conjugation, so that we are counting lone pair also. Okay, so now you see here sp3, here sp2, here sp2. Okay, so now if you go for basicity, you will get to know this one is more basic. Why? Because S character is less. S character less means it can easily give lone pair. Okay, this is more basic, then this one, then this one. Okay, so now this is also sp2, this is also sp2. I am making little twist and making one more compound here, aniline, NH2. Okay, now can you tell me the hybridization of this nitrogen, whether it is sp2 or sp3? Now this here one lone pair is there, and that lone pair also under conjugation. Since that lone pair is under conjugation, that is also sp2. Now see the comparison: sp3, sp2, sp2, sp2. Now this type of molecule, once you are getting in exam, you get confusion, because if it is sp3, sp2 or sp, then it is clear. Okay, sp3 is more basic than sp2, then sp will be last. But 3 sp2 is coming. Now you have to understand one thing, that this lone pair is not going under conjugation. This lone pair is going under conjugation, and this aniline molecule, this lone pair also coming under conjugation. For plus M effect, this aniline, this lone pair is coming to this benzene ring. Okay. Now you have to understand one thing, that this molecule is aromatic, this is also aromatic, but here aromaticity is coming when that nitrogen lone pair is going to conjugation. That means this lone pair must be in conjugation so that aromaticity they can gain. But here is nothing like that. This molecule already in conjugation, already in aromatic. Benzene ring is already aromatic. Even though plus M effect is coming, it is okay. But here this lone pair must be in resonance so that aromaticity they can gain. So if I write the order, I have to write pyridine number 1, most basic, then pyridine, then aniline. Here aniline will come. Here aniline will come. And at last pyrrole will come. And H. Everywhere lone pair is there. Here also lone pair is there. Here also lone pair. Here also lone pair. Here also lone pair. This is sp3, so it is the most basic. Then sp2, sp2, sp2. This sp2 lone pair is localized, so it is more basic than other two. Now this is also delocalized. This is also delocalized. But this delocalized, without delocalized also molecule is aromatic. But this delocalization must show that aromaticity is there. So it is least one. Okay. Hope you got it. Let's give one more example. You can take a screenshot. One more example I am giving. Let's write pH C111 and pH CH2 NH2. Yes. Now here one lone pair is there. Here also lone pair is there. Now if you see, this lone pair is a part of sp hybridase. This nitrogen is what? sp hybridase. This nitrogen is sp, and in that sp nitrogen lone pair is there. But this nitrogen, it is sp3. In that sp3 nitrogen, this lone pair is there. So obviously if you go for basicity, which one will be more basic? Obviously below one is more basic than this one, because this is sp. Sp means more electronegative, so it is holding this lone pair more tightly, so it is not easy to give. Okay. Suppose you have it's shown its basicity, you bring some proton and it has accepted. That means basic. Initially it was basic. Now acidic form you got. NH plus pH CH2 and CH3 plus. Okay. Now examiner may make little twist, and they, instead of asking this acidity, this basicity of this molecule, they may ask the acidity of this molecule. Are you understand what I am trying to say? That generally this type of molecule they are asking the basicity, but they may already make the acidic form, yes, conjugate acid form, and they may ask now which one is more acidic. Now you have to understand, this was weak base. Weak base will produce strong acid. Now once we go for acidity, this one is more acidic than this one. And if you go for data, pKh value, if you are able to find out pKh value for particular this conjugate acid, you will shock to know that this particular molecule is 10 to the power 20 times more acidic than this one. So how I got to know that this is 10 to the power 20 times more? Because this is pKh is around -10, but this is pKh is +10. So +10 to -10, 20 difference. So that how much is difference in pK? That many times 10 to the power will be the difference of their acidity. So this is 10 to the power 20 times more acidic than this one. Hope you got it. So this type of molecule and this type of concept I will keep discussing. You subscribe my channel. Any doubt you can write in comment section. Thank you.